All right, this is a video that is going to contain several questions, as you can see, about possible sets of marbles. So not probability here, we're looking at all the possible sets with the given conditions, okay? Um, in the bag, I kind of color coded, but I put the letters in case, the screen doesn't show up well. Uh, we have 3 reds, 2 green, 1 purple, 2 yellows, and 2 orange. So total there, we could see there are 10 marbles, right? That's going to be important. So let's go ahead and just write that total 10 marbles. Okay, so we're not like um, creating probabilities here. So it's not like we're reaching in the bag and shaking these up and equally chance of drawing, right? So it really wouldn't matter. I drew a bag, just kind of common. They talk about throwing marbles in a bag. Okay, how many possible sets of 4 marbles are there? So when we create this, because we now looked at permutations and combinations, right? We have to think of a combination here. So why do we think combination? Because let's just say, for instance, I grabbed both yellows and both oranges. Okay, so I'm down here, I grab both of these. And that's one of my sets. It wouldn't matter if I name this set yellow, yellow, orange, orange, right? Or yellow, orange, or any combination of that. Those are all the same. If I grabbed, if I made a set of all the yellows and oranges here, they're identical no matter the order that I put them in. So in that case, remember that we call it a combination. All right, I'm going to go ahead and erase that. We definitely don't want to write all these out. Uh, let's go with like purple will look good. Okay. So we don't want to write these out. What we do is we think how many total, right? There are 10. And then we're choosing 4. It's a combination, so we do C. We often say 10 C4 or 10 choose 4. There are 10 total, we're choosing 4 of them. It doesn't matter, right, what color they are in this question. It's just all the possible sets of 4, so 10 choose 4. Now, definitely get out your calculator or put that in Excel. Right, combination 10 comma 4. Another way of maybe seeing this in certain textbooks is like this. And we could do all of these by hand, but we don't want to waste our time doing combinations by hand. Remember that the formula for NCR is n factorial over n minus r factorial over r factorial. So therefore we would have 10 factorial over 10 minus 4 is 6 factorial, 4 factorial. Again, I'm going to do this one by hand to kind of just show it can be done, but verify your answer with a calculator. All right, the shortcut here is bring this 10, remember factorial means multiply all the way down to 1. But stop at 6 because I have a 6 in the denominator, right? So those two are going to cancel. Now I still have 4 factorial, so I'm going to write 4 times 3 times 2 times 1. See, I didn't need to write 6 times 5 times 4 times 3 times 2 times 1 here because I would have had the same thing and it's multiply and divide here, right? So we could cancel. Now I could also look at cancel and like, I don't know how to count apparently. 10 times 9 times 8 times 7. Wow. Anyways, 4 times 2 is 8, so I could cancel that 8. Maybe that's what I was thinking. Saw it before I even wrote it. I don't know. And I also see 9 over 3, right? 9 over 3 reduces to a 3. So now I have 10 times 3, which is 30 times 7. 10 times 3 times 7. 30 times 7 is 210. And again, test that out in your calculator. Make sure you get 210. Good to go. All right, in each of the following now, we're going to have restrictions here. So in the next question, we're going to create a set of 3, but we have to have all the yellows. Okay. Well, there are 2 yellows. Some of these I'm going to show different techniques. We could strictly go by formulas, but here's one way of thinking of this. If I want a set of 3, and the 2 yellows must be chosen, let's go back to black here. Okay. So I have to put a yellow here and a yellow there. There's no other options, right? I'm choosing 3. I have to throw in all the yellows, so these 2 yellows are gone. Well, now there are 8 remaining. So I could pick a red, or I could pick a green or a purple. There are 8. The last color really doesn't matter. Since there are 8 remaining, we could think of it like just multiply by 8. In these where I took up the yellows, that would just be like one choice, right? I have to throw a yellow, I have to throw a yellow, one choice, and then 8 choices for the last. Or what you could think is 8 choose 1 for here. Okay, 8 choose 1. But anytime you have n choose 1, it will always just be that value, which is 8. Um, Strictly using the formula, we could say, all right, to get the yellows, I have 2 yellows, I have to choose 2 of them. But anytime you have the same values there, that's always 1. Okay, and then we have 8 other marbles, we have to choose 1, and again, that's 8. No matter how you look at it, 1 times 8 is 8. And that really makes sense, right? Because I could have done 2 yellows, choose the first red, 2 yellows, choose the second red, and so forth. Oh no. We'll just leave those marks there. I don't want to erase my marble. All right, set of 5 marbles, including 1 of each color. Well, this one isn't terrible because we only have 5 colors, right? We have red, green, purple, yellow, orange, so 5 colors. So really what you're thinking about here is if I do it that way, like we did above, right? I need 5 marbles, 1 of each color. So for red, I have 3 choices, right? For green, I have 2 choices. So those are my red, those are my green. For purple, I have only 1 choice. For yellow, I have 2. And for orange, I have 2. We multiply 3 times 2 times 1 times 2 times 2, and you get 24. So why does that work? Well, think of the counting principle, right? If you're choosing 1 of everything, you just multiply the total number of options of each selection together. So that was like kind of the start of the counting principle. But we could actually look at this as I had 3 red, choose 1. Multiply 2 green, choose 1. Multiply. Remember with creating sets like these, we're multiplying because it could have been one of these red, and then if I drew a tree diagram out, either one of those green, right? So it quickly expands. Anyways, 1 choose 1, 2 choose 1, and 2 choose 1. Remember, anytime you have choose 1, that really just equates to like 2 choose 1 is 2. So that's why we multiplied 3 times 2 times 1 times 2 times 1 using counting principles, using the combinations. Okay, moving on. Set of 5, including at least 2 reds. This one gets a little trickier because if I want to include at least 2 reds, I could have a set of 5 with 2 reds, right? Set of 5 with 2 reds. Or I could have had a set of 5 with 3 reds since there are 3 of them. So in this case, you need to look at all the possible ways of this, right? That option of using only 2 reds and adding, anytime you have that or, you want to think add. That's the one time you're not multiplying these combinations. Or, so add all the possible sets you could create using the 3 marbles. All right. Now, beyond that, in this first option here, there are 3 reds to choose from, and I'm only choosing 2 of them. So we have to create a combination to fill those 2 in. And the easiest approach, I think, to look at this is like this. For this first outcome possibility, I have 3 reds. I'm going to choose 2 of them. Okay. Now I have to fill in these remaining 3 here. So what is going to go there? Well, there are no restrictions, right? Except I don't want that last red. Don't count that last red, because otherwise I'm at this other scenario. So we have 3 choose 2. And then out of the remaining 7 non-reds, I need to choose 3, right, to fill those in. So these are our reds, these are our non-reds. Seven, so using a calculator, you could just compute all of it at once, but 3 choose 2 is the same as 3 choose 1, so we get 3. And then 7 choose 3, plug that in and you get 35. All right, that's the first set. So the second set now, I'm creating a set of 5 again with 3 reds. Well, if I'm choosing all 3 reds, right, then those are gone. We could just take them out, but mathematically, the reason why that becomes 1, 3 choose 3. 3 choose 3 is 1. Okay, 1. Now, again, we have 7 marbles to choose from. This time we only have 2 spots to fill, though. So 7 total. Choose 2 of them. And plug that in or use technology, whatever, or do it by hand if you want. You get 21. So 3 times 35 plus 1 times 21, you get 126. 126. Should probably go through and highlight all the results, but that's okay. All right, last one here. Again, a little tricky because there's an additional stipulation. We either need the purple one, because there's only one, right? Or exactly 1 yellow. But in both cases, if I choose the purple, I cannot use the yellow. If I choose the 1 yellow, I cannot use the purple. So we have 2 different scenarios again. Say we chose the purple. I'll just do it to the left right here. So say we chose the purple one. 2, 3, 4, 5. Well, that means this one is gone, right? There's 1 purple and I'm choosing it. Again, we get a 1. I wanted to write out the formula in case. You do it this way. Now, since I chose the purple, no yellows, right? I cannot look at these yellows. Not an option. And the purple's gone because we just used that too. So we have 7 other marbles to choose from. It doesn't matter beyond the purple and yellow, right? It doesn't matter if I pick the reds, greens, oranges, or any combination of those. So 7 marbles left. I need to choose 4 of them. Right? So that's one scenario. Scenario 1, purple gone. Scenario 2 is I chose exactly one yellow. One yellow. Okay, they don't add the stipulation of at least one, right? So I don't need to include two yellows, just one yellow. Well, there are two of them there, though. I need to choose one of them. To choose one. Now, like the other one, yellows are no longer an option. I cannot have two yellows, so I cannot count that in the calculation. Also, it says you cannot have both purple and yellow, so those are gone. So like the other one, the remaining 7 doesn't matter, and I have 4 spots to fill, right? So 7, choose 4. So 7 choose 4 on the calculator will give you 35. I'm going to scroll a little since we don't need it now. This would be 1 times 35 plus 2 times 35, or you could just do 35 times 3, right? Same thing. 1 plus 2 is 3. No matter how you look at it, plug that in a calculator, you get 105. 105 different sets you could create under those stipulations that are given.